Dear student, see this GOC unit of last topic, elemental analysis of organic compound. In generally, the organic compound containing elements carbon, hydrogen, nitrogen, halogens, phosphorus. The next, the nitrogen can be analyzed by the two method. One is a Dumas method, okay, Dumas method, and another one is a Kjeldahl method. Okay, there is a second case as there is a Kjeldahl method, Kjeldahl methods. So these two is a very important. The Kjeldahl method as well as the Dumas method, both as a the estimation of nitrogen is very important, and the estimation of halogens, that is for the Carriers method. Okay, the halogens are estimated by Carriers method, and the estimation of the sulfur and as well as phosphorus and oxygen. So those is simply given in that formula based on that laboratory method. The first case, in generally, the organic compound if containing the carbon and hydrogen that undergoes the combustion reaction. Okay, there's a combustion reaction. If the compound is containing carbon, it will give the carbon dioxide, and if that compound has a containing hydrogen, it will give us a H2O. Okay. So from that we can calculating the percentage of carbon. The percentage of carbon here, the carbon is converted into carbon dioxide, hydrogen is converted to water. So anywhere the percentage of carbon that is equal to, there's a 12 into m1 m2 into 100 divided by 44 into m. Okay, so this is for that in generally the 44 as the carbon dioxide molecular weight. The carbon dioxide has a carbon of mass as a 12, oxygen of mass as a 16 into 2 times. So we can get there is a 12 plus 32, that is equal to 44. Okay, that is equal to, there is a 44 gram. Okay, so each carbon is converted into carbon dioxide. So carbon of mass as a 12 and the carbon dioxide of mass as a 44. So from this formula we can estimate the percentage of the carbon in the organic compound. Then next, if we containing the hydrocarbon or organic compound, the hydrogen. So the hydrogen of percentage of hydrogen, that is equal to the mass of hydrogen. What? There is a hydrogen molecule. Yes, the each hydrogen atom is containing a molecular atomic mass as 1. So molecular hydrogen, that is 2. So into m1 into there is a 1000 divided by that is 18 into m. Here this 2 as a H2 of mass as a 2 gram. And this 18, there is nothing but H2O is a molecular mass is nothing but that is for 18 gram. Okay. From this formula is a very important. We can finding the how much percentage of hydrogen are present in the entire organic compound. Next we go to that estimation of halogens. Okay, so this estimation of halogens in that Carriers method. What method? It's a Carriers method. So these methods can be estimated the percentage of halogens. In general, the Carriers method, the nothing but it is the organic compound is taken as a sealed tube in presence of silver nitrate. So the carbon and hydrogen present are oxidized to carbon dioxide and water. Whatever that the remaining case of halogens react with silver nitrate to give the precipitate of silver halide. Okay, the reaction, there is a halogens for organic compound with the halogens, they have reacted with the silver nitride. Okay, silver nitride, we can get the silver halide as a precipitated. So this silver halide, from that we can finding the percentage of halogens. For example, the percentage of chlorine, that is equal to, actually the each chlorine mass, that is equal to 35.5, and into there is weight of the silver chloride divided by there is the silver nitride mass. Actually there is a 143.5 into there is weight of compound, weight of the organic compound into as a 100. Okay, so this is the percentage of chlorine. Finding the formula, it is also very important. The next case, the percentage of the bromine, that is equal to, each bromine is containing the mass as a 80 divided by 80 into the similarly there is weight of silver bromide divided by that is for 188 into there is a weight of organic compound into as a 100. Okay, the next case, the weight of or the percentage of iodine. The percentage of iodine, that is equal to the iodine of mass as a 127 into that is for weight of the silver iodide, the weight of the silver iodide divided by that is for 235 into that is weight of organic compound. Okay, weight of organic compound into 100. So these three formulas are very important. There is a most basic fundamental of the percentage of the halogens are present in the particular organic compound. It is nothing but there is a for Carriers method. Next is the estimation of sulfur. Okay, there is a estimation of sulfur. So this estimation of sulfur, this also is carried out in the Carriers method. Actually, there is an organic compound with or it containing the sulfur atom. So this compound, the sulfur is converted into there's a barium sulfate. Okay, so that's why this treated with the barium chloride. Okay, so this is a barium chloride followed by oxidation, it will convert that to barium sulfate. So this barium sulfate is the most basic fundamental of the formation of sulfur is converted into the barium sulfate. So here the percentage of sulfur we can get it. There is the 32 into there is a weight of barium sulfate, divided by that is for the 233 into weight of organic compound. Okay, there is a weight of organic compound into as a 100. So this formula is a percentage of the sulfur we can find it. Then next, the estimation of phosphor. Okay, so estimation of phosphor we can get, how we can get, that is the phosphor if containing that organic compound, it will convert to that there is a ammonium phosphate. Okay, so for that reason we can finding the percentage of phosphor. The percentage of phosphor that is equal to the 62 into that is for weight of magnesium phosphate P2 Mg2 P2 O7 whole divided by that is for triple two into that is weight of the organic compound. Okay, weight of organic compound into as a 100. So this is for the estimation of the phosphor as a formula. The next case as a percentage of oxygen. The percentage of oxygen, or there is a percentage of oxygen we can finding that the oxygen is generally is converted into that carbon dioxide. For that reason we can go to that there is a 32 into there is a weight of the carbon dioxide, or here there is a m1 in divided by there is a 44 into m. This m is a weight of organic compound, this is the weight of the carbon dioxide. Okay, so into as a 100. This is the estimation of the oxygen in the organic compound. Okay, the estimation of nitrogen. It's a estimation of the nitrogen. Okay, so this estimation of nitrogen actually there's a two method. One is for there's a Dumas method. Okay, Dumas method, and another one is for there is a Kjeldahl method. Okay, so this Kjeldahl method for only for whenever that organic compound is containing nitrogen, they have converted into there is for the ammonia. Actually there is a only nitrogen is converted into ammonia. When that nitrogen is converted to ammonia, like that organic molecules, they have only analysis, only this they have analysis in the Kjeldahl method. The remaining this Dumas method, this are all organic compounds, especially nitrogen containing all organic compounds, they have estimated in the Dumas method. Okay, so let's see that one by one. First case as a Dumas method. Okay, the Dumas method. This Dumas method, they have the nitrogen is converted into nitrogen containing organic molecules, they have converted into nitrogen molecule. Okay, in general equation there is a CXHYNZ plus there is a CO, cuprous oxide or copper oxide is reacted with, we can get X of the carbon dioxide plus X by 2 of H2O plus Z by 2 of N2 plus as a copper. Okay, so this nitrogen can be collected in the Dumas apparatus. Okay, so this nitrogen we have collecting the particular volume. Okay, this particular volume, in generally we know that 1 mole of gas is occupied in that 22.4 liter volume, or there is a 22,400 milliliter of volume. Okay, this is a 1 mole of gas is have be occupied. Let's see, they take off the organic compound we have containing there is a the actual the organic compound containing nitrogen. So we can finding the volume of nitrogen that is equal to P1V1 into 273 divided by that is 760 into T1. So this formula is the most useful for the volume of the nitrogen, or particularly presented in the organic compound. Okay, this formula is particularly useful for volume N is equal to P1V1 into 273 divided by 760 into T1. Next, if we finding that the volume of nitrogen, we can go to that the percentage of nitrogen. Okay, so there is the percentage of nitrogen that is equal to that is 28 into V into 100 divided by that's 22,400 into M. So this formula is used for the finding the percentage of nitrogen whether the organic compound is containing nitrogen. We can convert to that nitrogen is in the molecular nitrogen, and finally we can get the volume of nitrogen. That volume of nitrogen can be used for the percentage of nitrogen. Okay, so the next case there is Kjeldahl method. The second case is the Kjeldahl's method. So this Kjeldahl method, actually the nitrogen is converted into ammonia. That is organic compound containing nitrogen is converted into ammonia. We know that ammonia is a base. Okay, so that's why we can take it as the ammonia. It will convert in the gaseous form to, whenever reducing the temperature, it will convert the ammonia of the liquid. So this liquid ammonia goes to titrated against the concentrated H2SO4. So that has known strength of concentrated H2SO4. For example, the H2SO4 plus 2 mole of NH3 gives the NH4 2 times and SO4. Ammonium sulfate as a formation occurred. So from that reason, the percentage of nitrogen here, the percentage of nitrogen is equal to that is 14 into capital M into there's a 2 into V minus V1 divided by 2 whole divided by there is a 1000. Okay. So this is one of the formula, or we can go to that there is a 1.4 into capital M into 2 into V minus V1 divided by 2 whole divided by there is a M. Okay, so this is one of the formula. Okay, so now we can use this final formula. This is the percentage of nitrogen. So this is a very important, especially NEET and JEE level problems asking. Whenever that the GOC topic is covered, the numerical problem, that is only asking the Dumas and Kjeldahl method, or that remaining part of the elemental analysis. Okay, thank you. If you like this video, you can subscribe and share your friends. Thank you very much.